Hello, everyone. My name is Maribel Bautista Tana, and today my team and I are here to talk about our capstone presentation, Security Search Hub. Our team is comprised of 4 members: Liam Murphy, Austin Shadell, Alyssa Sharp, and myself. Now, let us first discuss the motivation behind this project and our clients. For this project, our clients were TLDRSec, which is short for Too Long Didn't Read Security. TLDRSec is a popular security-focused blog and newsletter with over 5,500 subscribers, ranging from security engineers to security managers, chief information security officers, and startup founders from companies like Google, Facebook, Netflix, Slack, Cloudflare, and many more. This term, we work directly with Dr. Clint Gibler, who is the CEO and co-founder of TLDRSec, as well as the head of security research at R2C, and Dr. Daniel DeFries, who is a chief scientist and co-founder of TLDRSec, as well as an assistant professor of computer science at Southern Oregon University. In the field of computer security, the most common way of distributing knowledge is through giving a talk at a conference. Thus, the community's collective knowledge is spread across dozens of conferences in different formats and varying degrees of organization. These conferences host hundreds of talks every year worldwide that provide a plethora of rich and useful information from experts across all fields. And while a large portion of these talks are available online, they are scattered between individual conference websites with no central repository or data format. This is a problem for researchers as they may have a difficult time finding this information. Our proposed solution for this problem is Security Search Hub, a search engine web application that indexes all talk-related media from cybersecurity conferences around the world. Now that wraps up the motivation section of our presentation. Here to talk about the major requirements and features is Alyssa.
Thank you, Maribel. Hi, my name is Alyssa Sharp, and today I'll be talking about SSH's major requirements and features. Our goal was to create a functioning web application that allows a user to search for conference talks that have been delivered at past computer security conferences. Another goal for our project was to implement responsive filtering to give users a more pleasant experience while using our application. And finally, we wanted to create a back-end pipeline that communicates fluidly with our front end. Beginning with our search engine, we wanted to create a functioning homepage that's easy to use, easy on the eyes, and provides convenience for the user. The homepage will allow the user to search for conference talks through the main search bar or through advanced searching through the filters that are located on the left-hand sidebar of our web page. These filters will include conference names, years, and relevant tags. Our team has prioritized creating a fluid and quick experience for retrieving the data. This is why we wanted to implement responsive filtering. The user can check the boxes located next to the filter to enable the filter they want to use. As the user selects different filters, the sidebar list updates to show only relevant filter options, along with the number of conferences related to that selected filter. Finally, our team has created a back-end pipeline, which is written in the programming language Python. The pipeline scrapes the web for conference talks, in which that data is brought into our pipeline, that then normalizes it so it can conform to our data scheme that our front-end application will expect. We also have a data enrich step, which is explained in the next slide. Our pipeline's job is to ensure consistency of all our talk data from all of our sources so our front-end application can read it correctly to then present it to the user. For an example today, we have a conference talk JSON file from HackerTracker, one of our data sources. And as you can see on the left-hand side, it has an ID, description, speakers, conference name, title, and tools. This JSON file will be sent through our pipeline to be normalized and enriched, which will then be transformed into the JSON file on the right-hand side. As you can see, the description has become an abstract. The speakers are now authors. Appropriate tags have been added to the JSON file, and there is now a talk tool white paper slide URL, which will then link to YouTube videos, slides, or GitHub repos. Another thing that you might notice is that there is a conference parent. Because DEF CON is a yearly conference, we have given all conferences that have occurred at DEF CON the same parent. This process is performed for each talk received from our data sources. This wraps up the major requirements and features section of our presentation. Here to talk about tools and technologies is Liam.
Thank you, Alyssa. Hi, everyone. My name is Liam Murphy, and now I will be talking about SSH's tools and technology stack. So beginning with the front end, the core component of the front end for SSH is the Vue JavaScript framework. Vue allows us to write important logic into the UI to implement some of the previously mentioned features, such as searching and responsive filtering. Vue is made up of several languages, those being HTML, CSS, JavaScript, and TypeScript, and we can leverage all these tools to build a cohesive web application. The backend begins with our ingestion pipeline and ends with our REST API definition to the GUI. As explained previously by Alyssa, we scrape talk data from our various sources and normalize and enrich them to conform to our internal data schema and add in any relevant information, such as links to the video presentation for the talk. This generates a large file containing an array of JSON objects of the transformed talks. That JSON file is then uploaded to AWS Cloud Search. Cloud Search ingests JSON file documents and indexes them on a per field basis. So for example, you can have field names such as talk name, conference, etc. for easy searching. Cloud Search provides the core storage and search engine functionality of SSH. Next, we have an AWS Lambda function written in Python that takes in search queries from the web application and builds a compound query to retrieve data from Cloud Search. A compound query is a structured string that defines what data we want from a particular field or even from many fields. And this is how we build the queries that get the data that we want from Cloud Search when a search query is made from a user based on their search term and the filters that they specify. This can be seen as akin to a SQL query. And finally, our REST API is defined in AWS API Gateway. We have different endpoints for search queries and for metadata that populates the responsive filtering navbar. And now here's a bird's eye view of our app explaining the flow from the very beginning of the ingestion pipeline to displaying the content to the user in the Vue app. Take a moment and pause if you need some more time to understand the data flow. This wraps up the tools and technology sections of our presentation. Next up is Maribel presenting a demo of the SSH web application.
Thank you, Liam. Hello everyone, Maribel again, and I'll be doing the demo for SSH. And as you can see here, this is the homepage for our application. Currently, we have it set to display 20 random talks to users by default. And this is done either at page load or whenever users perform any blank searches. And we've done this so that at any given moment, users are always presented with some type of content. On the left-hand side of the page, you'll see this sidebar, which can be used to filter by 3 different categories, those being tags, conferences, and years. We've also added in a reset filters button, which users can use to clear out any of these filters. There's a search bar that allows users to perform searches that they'd like. And lastly, a navigation bar with a couple of different links, those being the home page, the About TLDRSec page, the New Resource button, and a user drop-down menu that at this time does not have functionality but will be implemented spring term. We've also added in an About TLDRSec page, which contains some information about the company as well as their founders. And we've added in a button that links out to the blog. If users visit the New Resource button, they'll be greeted by a form that they can fill out to submit a talk that is not currently in our dataset. We also hope to amend this in the future so that users can add in partial talk information. For example, if a talk is missing a video URL, users will be able to provide us with this information. Again, this functionality is not available, but will be implemented in spring term. Now I'll perform some basic search queries. So let's look at talks that have to do with ransomware. And as you can see, we have 23 talks in our data set. And let's look at talks about security that have the tag malware. And currently we have 49 talks in our data set. And it's important to note here that this sidebar is responsive in that it is updating to current data based off of what filters and search terms are being provided. And lastly, let's perform a more advanced search using only filtering. So we'll want talks that have the tag malware and machine learning and are from the conference DEF CON and took place in 2018. And currently we have 5 results in our data set. And a brief overview of our talk cards. They contain the title of the talk, the conference that it belongs to, in this case, StepCon 26, and the year it took place, which is 2018. We've also added in a section for applicable tags, a section for authors, and a section for the abstract. Lastly, we have these external resource icons here on the right, which are used to link out to either the white paper, the video, the slides, or the tool for that talk. So here is an example of a video for a talk, the slides for a talk, and lastly, the tool. And usually these are GitHub repos for the talk. And here we have an example of a white paper. And that concludes the demo for SSH. Here to talk about the testing we conducted is Austin.
Thank you for that awesome demo, Maribel. Hi, everyone. I'm Austin Shadell, and I'm here to talk about SSH's use cases and unit tests. First off, we'll talk about the front-end use cases and subsequent test cases that were decided upon to be tested during this first term version. Our first version of the web app focused mainly on implementing test cases related to guest level privileges, as this will obviously be the main user type on our application. Cases such as searching for talks, viewing talk information, and the use of filtering were very important because these are core functions of our system every guest will interact with. As you can see in the winter term column, we include cases which have been implemented in past. You can then notice in the spring term column, we include test cases which pertain to features not yet implemented, so of course they do not pass by default. We do hope to have more features implemented over the course of spring term, which will pass all our current test cases for them. Now we will move on to our pipeline unit testing. Our backend data pipeline written in Python is an extremely critical system as it handles all data cleaning and transformation before it is uploaded to AWS Cloud Search and then seen by an end user, as Maribel demonstrated. Unit testing helps to ensure that important functionality with our pipeline is working properly. Many unit tests were written mainly for our normalized and enriched data classes, as these contain many of the mission critical functions. Some of those functions include methods of data transformation from source to match our internal schema, adding data to existing entries, ensuring schema also aligns with the AWS Cloud Search expectations, and of course, methods to make sure the pipeline is working without error. This wraps up the test cases and pipeline unit testing portion of our presentation. Thank you.
Now our team will talk to you about the division of labor. I spent most of my time working on front-end development with Vue functionality, but I also worked on Lambda functions and the pipeline.
This term, I predominantly worked within our Vue functionality and AWS Cloud Search.
I focused primarily on the ingestion pipeline, but also worked as needed in Lambda and Cloud Search and Vue.
My time was mostly spent within Lambda writing Python code to query Cloud Search, along with some time spent on the ingestion pipeline.
And now for a conclusion, we will begin with our roadmap. So for our documentation, we followed the waterfall methodology. We did all the documentation for the class as needed. And then looking at the roadmap for the development phase, we followed the agile methodology. The demo that Maribel presented is a result of completing sprints 1, 2, and 3. And if you like, you can pause to look at each bullet point to get a general sense of what we did. And then beginning with number 4, we are doing the presentation. And then we begin with spring term, where some of our team members will be switching to some different roles that they want to do that they couldn't do this last term. And then for V2, our finished product hopes to add some additional features, such as parsing talk transcripts and slides for external resources, deduplicating authors so that we can create entire author profiles, and enriching our data with social media links.
Now for our next steps. So far, what we have completed amounts to an easy-to-use search engine that allows users to sift through over a couple thousand talks. This hits the mark for what we hope to achieve this term and more. For spring term, we hope to complete goals like scraping for more data sources, setting up a login system, and adding in more information about the authors themselves. Thank you.
This wraps up our video presentation on our SSH capstone project. Thank you for taking the time to listen, and we hope that you enjoyed learning more about our project.